What's up, guys? We got our 7th and final video of the chapter. Now this one's all about titrations, and so let's run through it. 42.3 milliliters of 0.285 molar HCl were used to titrate an NaOH solution having a concentration of 0.714 molar. What volume of base was needed? So the key to this is that anytime we're doing titrations, it focuses on the key that the moles of our acid, or our H plus ion concentration, have to be equal to the moles of our base, or our OH minus concentration. Why does this keep happening? And so with this in mind, when we're setting everything up, it's easier if, based on this idea that moles of acid is equal to the moles of our base, if we set everything up knowing that molarity is equal to the number of moles over liters. So if we're trying to solve for the moles of something, the number of moles would be equal to the molarity multiplied by the liters of our solution, right? So that means that if we're trying to figure out the moles of our acid, it's the molarity of our acid multiplied by the liters of our acid. And the same would be true for our base, the molarity of our base multiplied by the volume of our base. And so we're going to use this equation to kind of help guide us through to figuring out the volume necessary of our NaOH solution. And so our first step then, using our equation here that we just kind of figured out, we'll put little A's for acid and B's for base. The molarity of our acid was 0.285. And the volume of our acid was 42.3 milliliters. However, remember, we do need to change it to liters. And so when we change it to liters, we just divide by 1,000. So when we divide by 1,000, we get a volume of 0.0423 liters. And we set that equal to our 0.714 molar base multiplied by the unknown volume of base. So we'll just put LB. And so now, when we're trying to figure everything out and solve, we'd multiply 0.285 by 0.0423, and then divide by this 0.714. Once we do that, we get the liters of our base has to be equal to 0.0169 liters. And that technically answers the question, but just to kind of put it in perspective, if we wanted to put that into milliliters, remember all we need to do is set up a short picket fence and multiply the number of milliliters per 1 liter, and this will pump out 16.9 milliliters. So if we were doing this in the lab, it would take 16.9 milliliters to titrate our base here. So you guys have the second one for homework. 63.9 milliliters of 0.56 molar sulfuric acid was completely neutralized by 28.3 milliliters of potassium hydroxide. What's the concentration of the potassium hydroxide? You guys got it. Good luck. See you tomorrow.